Hi, in this video we will learn about the notion of higher derivatives for functions, and specifically we'll see what kind of notation we will use to denote those new functions. Well, remember that when we have a function, then we can form this ratio for any given x and find the limit of that as h goes to 0. If this limit exists for all x's, basically we have defined what is called the first derivative of the function. We denote it by f prime and we call it first derivative. But when you finish this process, you notice that you have got a new function and you can repeat the same process for that function. In other words, you can try to differentiate that function. This is a notation we will use for differentiating function. That f prime x, and well, if that exists, we will define a new function. This time we call it the second derivative. So this was the first derivative. Then there will be second derivative. And you can continue this process. Like the third derivative would be like that, which is the first derivative of the second derivative of function. Then you see prime, double prime, triple prime. From the third one on, we put it in the bracket, round bracket, as power. F of bracket 4 means that we differentiate the function 4 times, or we just find the derivative of f3, and this goes on. Yes, so for the nth, we mean that this is the derivative of one derivative before that. Okay, well, in this book you will see that in this course you will see that we are using different notations. Specifically, the notations that you will notice, by the way, let me just write here, these are called third derivative, this is fourth derivative, and this is nth derivative. So but there are other notation. For example, first derivative, as we have been using, like this is the first derivative, and you can go ahead and write the second derivative by this, the third derivative by this, and the nth derivative by this. This is nth derivative function. Or sometimes you will see me writing like dy, if y is equal to f of x, dy dx, d2y dx2, or d3y dx3, and this will go on nth one, dny dxn. See, the notation has some subtlety here. In the numerator, we put the number up on d as power of d, but in the denominator, we always write dx2, dx3. And there are other notations also, like one of the other things that you may see in other books is dx, then dx2f, dx3f, and in general dxnf. So these are the notation, but what is there? There is only one process, differentiating the function. And if you repeat this, you get the higher derivatives, and so on. Let's do some examples for this. For example, I have, I guess, 2 functions here for you. Okay, so this is the function. F of x is x squared minus 4x plus 1. We are trying to find f double prime and f triple prime, the second and third derivative. To do all these things, I need first find what is f prime x, which is given by limit of fx plus h minus fx over h as h goes to 0. And then this is specific, for this specific function, you see that I have x plus h squared minus 4x plus h plus 1 minus x plus h, sorry, this one just x squared, f of x, yes, minus 4x plus 1 over just h. In the numerator, you just open this, expand this terms. What you notice is x squared plus 2hx plus h squared minus 4x minus 4h plus 1 minus x squared plus 4x and minus 1 over h. You right away notice that this cancels with that, this cancels with that, this gone with that, and in the numerator we only have limit of h goes to 0 of h squared plus 2hx minus 4h over h. This is 0 over 0, but you can easily see that I can factor out h from the numerator, and that will give me 2h plus 2x minus 4 over h. These two cancel, and this is limit of h plus 2x minus 4. As h goes to 0, this is 2x minus 4. So f prime, let me just make sure that I have enough space here. F prime in this case is 2x minus 4. Now, we want to find f double prime of x. It means that do the same thing, but instead of using f, use f prime over h as h goes to 0. And this time it is even easier. So it is 2 times x plus h minus 4 minus 2x minus 4 over h. And well, if we expand all the terms in the numerator, we have 2x plus 2h minus 4 minus 2x plus 4 over h. And as you can see, plus 4 minus 4, negative 2x plus 2x. And what we get here is limit of h goes to 0 of 2h over h. And you can cancel these two. This is just 2. So what we found is that f double prime x is 2. What would you do for the third one? Okay, you do the same process, repeat the same process here for f double prime. So limit of f double prime, f double prime x plus h minus f double prime x over h as h goes to 0. And this gives me, okay, you see f double prime is constant. So if a constant you evaluate at any point, in particular x plus h, you get 2. And f of x is 2 over h. So what we found here is 0 over h as h goes to 0. Here, you see, I'm not taking limit. This function is 0. So I'm trying to find limit of constant. And by constant law, we have 0. This means that the third derivative of this function was 0. The first derivative 2x minus 1, second derivative 2, and the third derivative is 0. Later on, we will learn more differentiation rules and a nicer way to compute these ones, and you will see that in that case, computing higher derivatives is even much easier than what we are doing here.